Welcome back to Semicon West here in Phoenix. My next guest today is Ben Peecock. He's a Senior Director of the X-ray Division at Nordson Electronics and Test. Is it Test and Electronics? I'm quite sure which it is. But,
At the X-ray and Test Division, yeah.
X-ray Test Division. Okay, so welcome, Ben. Nice to see you.
Thank you.
Okay, so you've had a long pedigree actually with the doseage platform, as it was known. But you're currently heading up the division here that is looking at the semiconductor side. So you've got a new machine here, it's the XM Pro. For the benefit of our viewers that are not familiar with it, give us an overview of the feature set of the XM Pro.
Sure. So the XM Pro is a X-ray metrology tool. We're using it for wafer level inspection, so fully clean room compliant, robot loaded EFIM, and we're using it to make measurements from 2D or 2.5 or 3D inspection techniques, typically to finding defects, which might include avoiding within the solder bumps, but also in the 3D space, then looking at TSVs and also the interconnects and the quality of those.
As well. Okay. And what sort of range of metrology do you get down to? What sort of sizes and pitches?
So with the new Pro version, we're now looking at being able to accurately repeatable measurement of between 1.5 to 2 micron defects within the devices.
Wow.
And again, obviously it depends on the magnification, which triggers then the inspection times. So obviously we can run at very high magnification and get a very high resolution, but trying to get that right balance between throughput and finding all the defects.
Right, okay. So it's a fairly sizable machine, but your customer base for this is typically R&D labs or some of the larger customers or manufacturers in the industry.
Yeah, absolutely. And we're working a lot with R&D now as the advanced packaging market is sort of evolving. But obviously the aim is that once those become proven in the R&D space, that then they move into volume manufacturing as well.
Okay, so you really see this rolling out into the general OSAT community?
Yeah, absolutely. So as the volumes of advanced packaging progresses, and again, it's all about yield management, we see a sort of a big need for that growing in the future.
Right. Where is your biggest geographical market for this? Is it Taiwan? Is it Asia? Is it here?
It's global. Yeah, I mean we have a big install base in the US and in Asia, in Taiwan, Korea. Yeah.
Right. Okay, so it's global. Okay. Any other unique features of the system?
Yeah, so as well as kind of the imaging chain, which is the core technical differentiation, we manufacture our own X-ray sources and our own CMOS sensor detectors. And again, this Pro version that's kind of replacing the legacy system is really pushing the capability on the imaging chain. Right. We're also investing heavily now in the AI space, to actually using AI to really push the boundaries of what can be achieved with the defect classification and detection.
Right. So with these very fine geometries, does it take a long time to generate the imagery, or is it fairly quick?
I mean, it's fast, again, depending on whether you're running a 2D inspection where you can just scan through very fast, or whether you're running a 3D where, again, you have the option to capturing multiple images on each inspection point, and then the magnification and resolution you want to run at. So it can be from tens of wafers per hour, but it can be a lot slower if you're going to a full 3D inspection.
Yeah, okay. Yes, so Ben, one of the things that seems to be a concern is obviously dosage levels for certain sensitive devices in the market. How does this system help that?
Yeah, so we've been spending a lot of time with radiation dose management. From creating simulation models so we can actually run before we put devices in to model exactly what the radiation exposure levels would be. But we're also then working with advanced filters to cut down the low energy X-rays, which are not adding anything to that the visual inspection process because they're being fully absorbed.
Right.
So we can massively reduce that. But also then optimizing our imaging chain, so we're running very fast capture rates, so the tools are in there for a limited period of time. And then the final piece is then offering dynamic shielding. So we're actually able to provide shielding on certain parts of the wafer to protect those very sensitive devices.
Right. I mean, are these devices, is there a way that these devices track what their dosage levels are as they go through the manufacturing process?
Yeah, I mean, we're starting to hear more requirements of that. Obviously, as these devices are going through many phases, so being able to accurately record and measure at each stage is a critical to ensure the overall dose.
I'm just wondering how they maintain some sort of record with the product as it goes through its
Yes,
manufacturer's life.
so during the process as it goes through the tool, we will produce an output report so we can actually individually record each device on the wafer and what level of radiation it's been exposed to. So we can output that with the metrology data.
Yeah, makes a lot of sense. Yeah.
All right, great.
Okay, excellent. Great. Well, it certainly sounds as if it's continued to progress. I mean, I remember when you first introduced it to the market, a system about 5 years ago.
Yeah.
But it's great to see it coming into its own.
Thank you. Yeah, no, it's exciting times. So good with the industry sort of focus on advanced packaging, and really great to be playing a part in helping the development of those products as they come to market.
Absolutely. It's a very exciting time in the industry right now. Okay, so Ben, thank you for coming in and telling us about it today.
Thank you.